All right, the next lesson that we're going to be working on is volume of a cone. So previously, hopefully you remember that we're working with volume of a cylinder, and really it's exactly the same with the exception of one additional step. So to remind ourselves, right, we have this previous section of notes on volume of a cylinder, right, which is V equal to pi r squared times h, which, right, we talked about how pi r squared is a circle, area of a circle, times the height. So for today's notes, we're still working on that same idea, right? V equal to pi r squared times h, but there's a little bit of a difference here with the formula for the volume of a cone, which is 1/3. Okay. So from here to here, really what we do is after you find the volume of a cylinder, if you divide it by 3, right? That's what represents it here by the 1/3. It's a cone. So, if I haven't shown it yet, I'll be showing it later. But if you take the cone with the same dimensions, radius, height as a cylinder, right? If it's just as wide and just as tall, right? Just like how these two objects are, it would take, let's say you filled it up with water. It would take 3 cones filled up completely with water to completely fill this cylinder with the same radius and height as well. Okay, so that's why it's represented as 1/3. So we're going to go through these examples of finding the volume, but also other key features as well. Okay, so let's start with this. Also, you might see the formula written in one of two ways. Or you could see this as V equal to 1/3 times the volume of a cylinder, pi r squared times h. Or you might see this as V equal to the formula for the volume of a cylinder, pi r squared times h divided by 3. Multiplying by 1/3 and dividing by 3 mean exactly the same thing, right? Something that is 1/3 as tall, or if you cut it in 3 ways and you're keeping one section. So I primarily use this formula here. So just know if I'm using this, it means both things, and in the end, right, you can also identify which one is best for you. Okay. So we have this sideways looking cylinder here. So I'm going to write out the formula for the volume of a cone. So pi r squared times h divided by 3. Right, looks like the height of this is 8 centimeters, and the radius from the center of the base figure, which is a circle, to the edge is 6 centimeters. So let's plug those two values in. So 6 for r, 8 for h, and we're going to divide it by 3. Okay. Now it just comes to right. We're going to simplify this and evaluate it by using order of operations. Right. 6 squared is 36. We'll do 36 times 8. So let's use our calculator for that. Oops. 36 times 8 is 288. So I'm going to write that in front of pi here. So 288 pi divided by 3. Now you could multiply by 3.14 at this point, but I'm actually just going to simplify our numerical values versus pi. So we're going to divide 288 divided by 3. So let's put divide by 3. So 96. So our answer, you could write it as V equal to 96 pi, and this is centimeters, so cubic centimeters. I'll space this out. This could be your answer for the formula for the volume of a cone in this case. Or if we write our answer in terms of pi, multiplying by 3.14. So 96 times that. So 301.44. And still keeping cubic centimeters. All right. So it would take, right, let's say we had, right, 1 cubic centimeter looks like this, right, 1 cube. It would take about 301, almost, well, more than that, 301 of these tiny cubes to fit in this entire space. So that's how much space this cone is taking up. Okay. So for the most part, this is the example that we're going to be referring to when you find the volume of a cone, but these other two examples are finding other facets or other parts of a cone that we don't have outside of the volume. So for this first one, or sorry, this next one, determine the height. So we don't know what the height is. We're going to put in h in the diagram. I would always recommend write out the formula for the volume of a cone. It looks like the volume is 2 pi, the radius, right, 2 pi cubic feet, the radius is 1 foot. So let's plug in what we know, right? We know what V is, which is 2 pi. And then off to the right, we know that the radius is 1. And we don't know what height is, so we're going to keep h there. Now, whenever you have a fraction, I would recommend undoing that fraction, or getting rid of the fraction. So that's actually the first step that we're going to do, is because in order of operations, if we're trying to undo this in the opposite order here, we're trying to undo this group, or sorry, we're dividing and then undoing the group that's in the numerator. So we're going to undo division, so we're going to multiply both sides by 3. And this is actually the first step when you're finding a lot of other variables that isn't just the volume. So if we do that here, right, dividing and multiplying by 3, that cancels out, that equals 1. On the left side, we're going to have 3 times 2 pi, which is 6 pi, equal to, we'll do this together as well. 1 squared is just 1, so this will be 1 pi times the height. Now 1 is multiplying h, pi is multiplying by h. I could divide both sides by 1, but I'm going to divide both sides by 1 pi. And just a side note, if we don't have pi here, you would divide by 3.14. But since we do, that makes our procedure a little bit easier. Okay, let's cross out the 1s and the pi's here. So 6 divided by 1 is 6, and we get 6 equal to h. So our answer here of what is the height is 6, and our units is feet. Well, I should put height is 6 feet. Even though it might not look like to scale, sometimes when you have figures or diagrams, it may not. But as long as you're applying the correct inverse operations and procedures, you're good there. All right, and let's go to our last example, finding the radius. All right, so you can look at the formula for the volume of a cylinder. We have a similar example here. We're saying that the volume is 60 pi and the height is 5. So we do know the height in this case. So let's plug in into this formula. Even though we don't have a diagram, we can still plug in. So instead of v equal to, we'll have 60 pi equal to. And let's plug in to our numerator. We don't know the radius. So radius, I'll put question mark. But our height is 5. So like I said, right, a good first step here is to undo this fraction by multiplying both sides by 3, which is a part of the formula. This will be 180 pi equal to this stuff. All these items in the numerator, we can rearrange this. I'm going to put 5 at the very front, so 5 pi radius squared. And then we're going to divide both sides by 5 pi. All right, we're going to cancel out the pi, cancel out the 5, and then this other additional pi as well. And then on the right side, we're left with r squared. On the right side, let's divide that out. 180 divided by 5. Right, 5 cannot go into 1, but it can go into 18 3 times. With a remainder of 3, we'll bring down this last place value. 5 can go into 30 6 times, evenly. So we're going to have that this is 36 equal to r squared. If you remember from our last notes, we talked about using the square root to undo the square. So our final answer here is going to be 6 equal to r. So I know this is the same answer as the last one, but the last one, it was represented as a height. This one is the radius. So we're going to say that the radius is 6, and our units here is mm, which stands for millimeters. All right, so this is just an introduction on formula for the volume of a cone. We're going to get to some additional practice, and then after that, we'll be working out of the book with some other activities and as well as an assignment. But for right now, we'll transition to our assignment.